In this example, we're going to be looking at finding the gradient of a curve at a specific point on the curve. The example problem pair comes in two parts, A and B. I'll do two parts and then there's two parts for you to have a go at as well. So in part A, we need to find the gradient of the curve with the equation y equals x squared at the point where x equals -2. We start by finding the derivative of x squared. We have x squared. So first we multiply by the power, that gives us a 2 out front, and then we subtract 1 from the power, which just gives us x to the 1, which we can write as x. Once we've found the gradient function, to find the gradient at a particular point, such as x equals -2, we substitute in our value of x. There are two ways you can write the notation for this. You can write when x equals -2 and then substitute in and get your answer, or there's an alternative form of notation that looks like this. So we need to do 2 lots of -2, which gives us -4. So the gradient of the curve y equals x squared at the point x is -2 is -4. Let's represent that graphically. We have the curve y equals x squared, and we're interested in the gradient at x equals -2. We could draw a tangent at that point, and if we did so, the gradient of that tangent would be -4. In this one, we have f of x equals x to the power of a half, and we want to find the gradient at the point x equals 9. A similar kind of idea to part A, but the notation is slightly different. To find the derivative of f of x, we write that as f dash x. Once again, we multiply first by the power, that gives us a half out front, and then we reduce the power by 1 to give us x to the -1/2. You could, if you want, leave it like that, but I'm going to rewrite this as a fraction. I'm going to write it as 1 over 2x to the power of 1/2. You could also write that as 1 over 2 root x. Next, to find the gradient at x equals 9, the notation this time is to do f dash of 9. That's an instruction to sub 9 into the derivative. That gives us 1 over 2 times 9 to the half. 9 to the half is like the positive square root of 9, which gives us 3. Times it by 2 gives us 6 on the denominator, meaning the overall answer is 1/6. Before we represent this graphically, there's something I'd like to stress that people often get wrong. With this question, first of all, we found the derivative or gradient function, and then we substitute in the value. This method doesn't work if you first sub in the value and then find the derivative, because if you ever do that, your answer will always be 0. So the graph of x to the half looks like this. If we were to draw a tangent at the point x equals 9, it would look like this, and the gradient of that tangent would be 1/6. Okay, here's a couple of problems for you to have a go at for yourself then. Pause the video and then come back and check your solution against mine. Welcome back, here are my solutions. Well done if you got them right. If not, I'll go through how I got them now. So in part A, we need to find the gradient of y equals x to the power of 4 at the point where x equals 1. We begin by finding the derivative of y equals x to the 4. That gives us 4x cubed. Once we have the derivative, we can substitute in x equals 1 to find the gradient at that point. So to find the derivative at x equals 1, we write dy dx at x equals 1. Remember, like I said in the last example, if you simply want to write when x equals 1, dy dx equals, and then the answer, that's perfectly acceptable. Here we're going to do 4 times 1 cubed. 1 cubed is 1, multiply that by 4, we just get 4. So the gradient of the curve y equals x to the 4 at the point x equals 1 is 4. In part B, we have f of x equals x to the -1, and we want to find the gradient at the point x equals 3. First of all, we need to find the derivative of f of x. To do that, multiply by the power, that gives us -1 multiplied by x to the power of -2. We get that by subtracting 1 from the power, which we could write as -1 over x squared. Next, to find the gradient at x equals 3, we substitute in. So we do f dash of 3, which gives us -1 over 3 squared, which gives us -1/9.